Good morning, this is Dr. Turner for Fundamental Mathematics. Today we're going to be looking at comparing ratios. Just as we've mentioned in 4.1 and 4.2, you can always convert your ratio to a fraction if that's more comfortable to you. That's a perfectly acceptable method. Here we're going to try to focus on not using fractions to compare the ratios. Depending on the problem, usually you're looking at two different concentrations or two different recipes and trying to see which one has a higher concentration or which one has more. And of course, if you're comparing ratios, it's going to depend on how much you're putting into the recipe or into the concentration. One of the ways that we can do that is to try to expand the ratios. So think simplifying, but working backwards until we have a common quote unquote denominator or a common y term that we are comparing to. That's the most common way to do that. And if you're looking at your supplemental resources, typically the most common way to do that is by looking at tables. So we'll try to do that. And hopefully it'll make sense here in just a second, but we'll go ahead and jump right into it with 4.3. So let's say we had two types of lemonade that we were comparing, and one combines 2 parts lemon juice to 3 parts water, and one compares 3 parts lemon juice to 4 parts water. Question is, which one has the higher concentration? Now, if you're really good with fractions, you might be able to tell me that already. The idea is that we're going to take this, and you can draw your t-chart if you want to, but we're going to take this, call it x and y, and we're going to compare these and continue to expand until we have either the same y term or as close to the same y term as possible. So the first concentration, I have 2 to 3. And so I'm going to go up and compare it until I get to a common term with 3 to 4. So my multiples of 2 and 3, I have 4, 6, 6, 9, 8, 12, 10, 15, etc. For 3 to 4, I have 3, 4, 6, 8, 9, 12, 12, 16, etc. Now here, we're already pretty close. But I know that 3 and 4 have a common factor, and you could keep going. Here, if I look at 8 to 12 and 9 to 12, these are both comparing the lemon part, or the lemon juice part, to the same water part, 12 parts water. So in the first example, 8 to 12, 8 parts lemon juice to 12 parts water. In the second example, 9 parts lemon juice to 12 parts water. That means that the second ratio has the higher concentration. So on a multiple choice test, typically this is A or B, which one has the higher concentration. Okay. Now that number 12, I could have potentially kept going, right? So the question is, when do you know where to stop? At most, if you multiply the two second numbers, so 3 times 4, that'll give you 12. So at the very most, you have to go up to 12 to where they have a common ratio. Okay. Let's look at another example. Let's say in the same problem, I have a 2 to 5 ratio. So again, lemon juice to water. And in the second, I have, let's say, 3 to 7. Okay. So the first factor, first multiple that 5 and 7 have in common is 35. So when I make my chart, I'm going to need to go up to 35. So for the first ratio, 2, 5, 4, 10, and keep going down. Down to 1435. And the second ratio, 3 to 7, 3, 7, 6, 14, continuing down. So in the first ratio, I had 14 to 35. In the second ratio, I had 15 to 35. So once again, in this example, the second ratio had the higher concentration. Only slightly, but it did have a higher concentration. All right, looking at another example, in one recipe of, let's say, sugar cookies, I'm comparing 1 part sugar to 1.5 cups brown sugar. In the other, I'm comparing 3 cups of sugar to 5 cups of brown sugar. Now, on the first example, I have a mixed number. Typically, if we're looking at ratios, we don't want to have a mixed number, which means I need to multiply this until I don't have a mixed number. So if I multiply by a factor of 2, that would take care of the mixed number, which makes this ratio 2 to 3. Then the question is, which has the higher concentration of white sugar? So same thing, we're going to make a table. The first multiple that 3 and 5 have in common is 15. So on my chart, I'm going to need to go up to 15. So 2, 3, 4, 6, 6, 9, all the way up to 10, 15. In the second, 3, 5, 6, 10, 9, 15. So the first ratio is 10 parts white sugar to 15 parts brown sugar. In the second, I have 9 parts white sugar to 15 parts brown sugar. So in this example, the first ratio has the higher concentration. That's it for today. If you have questions, please reach out during office hours. Otherwise, have a good day. I will talk to you soon. Bye.